My name is Catherine Kidman. Today I'll be presenting how Penfolds use database decision metrics to help plan and adapt to growing grapes in a changing climate. But first, let's have the history of Penfolds. The Penfolds journey began in 1844 with founders Dr. Christopher Rawson Penfold and his wife Mary left Britain for Australia. Armed with a vine cutting and a bold vision, they settled in McGill, where I am today, near Adelaide in South Australia, and they set up a medical surgery and a vineyard. In fact, the first Penfolds, made from the variety Grenache, were supplied as tonics to help Dr. Penfold's anaemic patients. Innovation, courage and foresight have always been at our core. Over time, the business grew, and by the 1870s, the estate comprised of several different varieties across 60 acres, supplying the growing domestic markets across Australia and contributing to 1/3 of South Australia's wine production. The distinctive Penfolds house style is the key that unlocks our ability to make wines across the world. Our winemakers interpret the terroir while staying true to the Penfolds red stamp. Everything to do with winemaking between the sun above and the soil below is Penfold. Now in our 180th year, Penfolds is committed to making a positive contribution to the world of wine. Penfolds' unique style is because of multi-region sourcing. We have always done this. We do have a combination of both company and grower vineyards. Some of the grower vineyards span multiple generations. Penfolds company-owned vineyards are located across the globe. We have wine regions in Australia in some of Australia's premier wine-growing regions, including the Barossa Valley, Coonawarra, and Henty regions in Victoria and down in Tasmania. More recently, Penfolds have expanded into California, with vineyards in the Napa Valley, Sonoma, and Paso Roble vineyards. Our first presence in America was back in 1998 with the purchase of the Camata Hills vineyards, and we planted with material sourced from our Australian vineyards. We have also expanded into France, in Bordeaux and Champagne, as well as China, in the Ningxia and southwest Yunnan provinces. We know our vineyards are exposed to the risks associated with climate change, and we know there's an urgent need to understand how climate change will impact each of our individual vineyard sites and locations. To provide some context, let's look at some recent observations of climate change. The first chart, sourced from the Australian Bureau of Meteorology, describes the frequency of extreme temperature events over time. Alarmingly, we can see an increased frequency of warmer than usual temperatures over the last decade or so. The next chart describes the deviation from the long-term average winter rainfall in the Barossa Valley. This data also shows an alarmingly drying trend for the winter period. And if you look at the last decade or so, you will see more often than not lower than average winter rainfall. And this has implications, as if we don't recharge our soil moisture profiles, we put pressure on irrigation and water resources. If we consider temperature accrual in the Barossa, over the last decade or so, you will notice the increased volatility as we've experienced the warmest seasons on record. From a global perspective, the latest news is that the planet is warming at record rates, with 2023 the warmest year on record at 1.48 degrees Celsius higher than pre-industrial standards. This variability highlights the importance for Penfolds to both mitigate and adapt to a changing and highly variable climate. So how are Penfolds modelling climate change? Well, in 2019, Wine Australia developed a foundational document that detailed climate change in the near, mid and late centuries for all the Australian wine-growing regions. This foundational document helped Penfolds understand the climate change risks for our regions. We know there are many influences and nuances, from topography to microclimates. This chart shows the graphic of growing season temperature differences from within the Barossa Valley. We know that we need to investigate these climate nuances and how they impact our individual vineyard sites. We've worked with leading climate scientists and our technical viticulture team to identify a range of metrics and how they specifically impact these individual vineyard sites. So how do we model these workflows? Well, our climatologists access global models, actually 6 parent global circulation models, or GCMs, that are publicly available and internationally recognised. We then select target archives that are relevant for our particular locations. The model performs assessments of projections and calculates climate metrics. We then take these outputs and perform site-based risk assessments for the mid and late century horizons. We transform these metrics into insights to plan adaptation and mitigation strategies for our vineyards. The outputs include large data sets of climate metrics and variables that we can perform these risk assessments upon. We also have visual tools to help understand and communicate these climate shifts. Climate scientists model outcomes based on relative concentration pathways, or RCPs, that are impacted by differing greenhouse gas concentrations. We started with multiple RCPs, but for the current projections, we've landed on RCP 8.5. RCP 8.5 is considered the worst case scenario, but is also the trajectory that we are on. And if we can solve for the worst case, then the other scenarios we should also be able to solve for. Our model combines data from high-resolution, dynamically downscaled climate projections. Resolutions vary across the globe. The highest resolution is at 5 kilometres squared, with the lowest at 50 kilometres squared. Our model is iterative. It currently uses data from the Coupled Modelled Intercomparison Project 5, or CMIP 5. But when CMIP 6 is released, for example, the model will iterate and the outputs will be relevant for the most current data that is available. For Penfolds, our focus starts with viticulture. We know that our vineyards are exposed to climate change under the high emissions scenario. Based on our assessments, we have grouped our risks into the following categories: heat events, rain events, varietal suitability, water availability, total water supply and demand. We've just completed site-specific climate-based risk assessments on our Australian and American vineyards, and we've developed a database dashboard tool like the graphic you're seeing now. This has allowed us to identify the key strategic and operational responses required to form the basis of adaptation and mitigation plans. So what are the high-level trends? Of course, in the absence of mitigation. We know that into the future we will see variations in yield, quality and fruit exposure as flavour and colour decouple from sugar under higher temperatures. We know that our growing season temperatures are going to get warmer, and this could lead to compressed vintages and also challenges the current varietal suitability of our regions. We know that we will have an increased aridity, and this could impact availability of water and the supply of water. There will also likely be an increased frequency of extreme events, such as frost, flood, and heat. And finally, an increase in pest and disease pressure, as well as bushfire or wildfire risks and smoke taint. Increasing our resilience to climate change is really about understanding these site-specific risks and how they impact our vineyard operations at a site level. One of Penfolds' strengths is our multi-regional sourcing model that we have. However, we still need to trial and experiment on a number of options to help us mitigate and adapt to the future climate. We are exploring changes to vineyard management and redevelopment standards. We are looking at water conservation, including trialling satellite-based soil moisture monitoring equipment, covering our dams to reduce evapotranspiration, and the use of recycled water. We have a covered vineyard experiment to help mitigate against rising temperatures in the Barossa Valley. This is across 14 hectares of Shiraz and Cabernet Sauvignon. And we are also investigating the role of evaporative cooling systems. Finally, we are looking at row and vine orientation, as well as alternative emerging varietals. There are, of course, the shorter-term challenges, as climate change is impacting our vineyards today. So how are we using data to help us proactively plan for the weather that's impacting our current vintages? Penfolds have a large data-rich history that enables us to use machine learning models to give us yield, quantity and harvest date timings. This enables us to proactively plan for the season and the weather ahead. For Penfolds, short-term adaptation starts with accurate seasonal weather, crop and growth stage forecasting. We access 7, 14 and 180-day weather outlooks gridded to each vineyard location. We work with meteorologists to help us interpret this data, as well as the impacts of the forecasted seasonal outlook. This is particularly relevant at key phenological stages of the season, including during frost susceptibility, flowering and fruit set, and ongoing proactive alerts around extreme weather events. These services help with group discussions and planning strategies throughout the vintage season. Climate change is impacting and will continue to impact our wine industry. Understanding these site-specific climate-based risks is essential as we work to adapt and mitigate to growing grapes in a changing climate. As we have shown, data forms the backbone of our decision-making processes, and this enables Penfolds to be future fit, to be able to continue to grow grapes and make luxury wine for now to evermore. I'd like to thank Harvard University for the opportunity to present to you today and for the technical support to bring this virtually from McGill to you at Harvard. Thanks to my team at Penfolds for their assistance with the presentation, to Tom Remini at Acclimatised, and finally, thank you, the audience, for your attention.